Welcome to ERC Tipsnology. In this video, we will be learning how to do mesh analysis in a series parallel circuit with two voltage sources. Let's start. So, in the start of this circuit, we will be drawing a circuit here with 10 volts. So let's put plus and minus 10 volts. And then let's put a resistor over here, followed by another resistor. And let's put another voltage source, our second voltage source over here. And let's say they are like in series, right? But let's put another resistor on this node on the right side. Let's make it simple. Let's just put one resistor here. And let's make a value of 4.7 kilo ohms over here. And this one, let's make this 6.8 kilo ohms. And this one, let's make this 10 kilo ohms. And this is positive, negative, and let's put a value of 15 volts. Now, what we will try to do is to find out what will be the current that will go on these resistors and what will be the voltage drops also. But since we are having two voltage sources, 10 volts and 15 volts, the usual way that we use the Kirchhoff's voltage law, Kirchhoff's current law, current divider rule, or the voltage divider rule will just never work if you use it directly. So instead, we will be using another way, and that's what we call as mesh analysis. So in this technique, we can calculate a current loop here. So we will draw a loop here in a clockwise direction, for example. And let's say that this is to the right, going down, and then to the left. And let's call this loop as I1. Now, all you have to do is to draw another loop on the right side here and assume a direction. I mean, we don't really know what will be the final direction, but for now, we will think that the current is also moving in a clockwise direction. So, I'll put an arrow here, going up and to the right, and going down, and going to the left. As you can see, I have I1 loop here, and I'll make another current loop here, which I will call I2. Now, the next step is to analyze the circuit by using the Kirchhoff's voltage law, where we can say that the voltage on 4.7 kilo ohm would be equal to the product of I1 and R. Remember that we have the rule of Ohm's law that states that the voltage is equal to the current multiplied by resistance. We can interchange the position of the I and the R. We can say that voltage is equal to resistance multiplied with the current. It's the same. And so we will write here the given resistance, which is 4.7, like in this way. And I'll multiply it with the I, which is the I1. So I'll write it as 4.7 kilo ohm multiply with I1. But for the meantime, we will just cancel the kilo. But we know that all of our resistances will be kilo. So after we finish this, we know that these are all kilo ohms. But I did not write it here anymore. So this 4.7 I1 multiply with I1, I can write it like 4.7 I1. Is that clear? I hope so. And then on the right, we will have 6.8. So we will add that. We will write 6.8 kilo ohms. But we will write I1 also. But on this side, you will notice that there's a current going down here, which we call as I1, right? This is I1. But there's also a current going up, which we call as I2, and they are in the different direction. This is going down and this is going up. Therefore, our equation would look like I1 positive and the I2 will be subtracted from I1 because the directions of the two are not the same or different. And let's continue with the direction here of the loop I1. We will have 15 volts and this is positive going to the positive, so we will just write plus 15. And after that, going here, we will enter the voltage source 1, 10 volts on the negative or in the negative, so we will write minus 10. Again, 4.7 I1 plus 6.8 I1 minus I2 plus 15 volts minus 10 volts. That's our equation and we will make it equal to 0. Now, if you multiply 6.8 by I1, you will get 6.8 I1. And if you multiply 6.8 with negative I2, and this is positive, we would get negative. So, negative here, and you multiply 6.8 by I2, you would get 6.8 I2. Plus 15 minus 10, that's 5. So, we will have here 0. Now, the common terms I1, they are common, so we can add 4.7 and 6.8. So, 4.7 plus 6.8, let's turn it on. 4.7 plus 6.8, we will get a value of 11.5 I1. And we will subtract the remaining 6.8 I2. But in the case of plus 5, we will move it on the other side of the equation, and if you do that, the positive sign will become negative. And so, we will have this equation. This will be our loop 1 equation. Loop 1 or I1 equation. I hope you understand that. Now, next, we will go on the loop number 2 and we will follow the same way. Because there's no resistor here, we can start on the right. That's 10 kilo, so we will write 10. And the name of the current now is I2, so I'll write 10 I2. Again, I don't need to write kilo right now, so I'll just write 10 I2, which is actually the voltage on this resistor. And we are still using the Kirchhoff's voltage law. So 10 I2, and going back here, so this will look like positive. We will assume this negative. Now, when you go on the 15 volts, you will enter on the negative side. So I'll write minus 15. And you continue moving from here, going up. Going here, you will enter the 6.8 kilo ohms. And we have here I2. So we will write plus 6.8, but we have a problem because this is not the only current on 6.8 kilo ohms. This time, we are assuming that this is positive and this is negative. And so it's going up. So we will put here I2. But there's another current going here. That's called I1, right? So going up and going down, we have to subtract. We have to subtract I1 from I2 because they have a different direction. Just like what we did over here when we are going down to I1 and then I2 is going up, we subtract I1 minus I2. This time, we're going up I2 and this is going down, we subtract minus I1. I hope that's clear. And after that, we don't have anything else here. And since we started at 10, then we will just keep this 0. And let's multiply positive 6.8 to I2. We would get positive 6.8 I2. But when you multiply positive 6.8 to negative I1, what you would get is a negative number, right? So we will get negative 6.8 multiplied with I1. And this one will just copy minus 15, and let's copy this 10 I2. Now this is still not simplified, so we will have to put together the common terms, and this time I2 they are the same, so we can write it like 10 plus 6.8 I2, right? So we can write it again, 10 I2 plus 6.8 I2. Then this negative 15 or minus 15, we can move it to the other side of the equation. And when we do that, of course, the negative symbol over here will become positive, right? So let's put it there. It will become positive 15. Now the remaining is minus 6.8 I1, so I'll just write it, minus 6.8 I1. And so because of that, we can clearly see that 10 I2 plus 6.8 I2, if you add them together, that would be 16.8 I2 minus the 6.8 I1 is equal to 15. But then this is 2 and this is 1. Let's sort it. Let's put the I1 first before the I2. So I'll write negative 6.8 I1 first before the positive. So negative 6.8 I1, I did not do anything but move it on the left, and this one we put it on the right, so it's still positive or plus 16.8 I2 equals 15. And there you go, we got the second equation. Our second equation, let's call this as loop number 2, which is for the I2 equation. So this is equation number 1, and this is equation number 2. Now what we will do is we can use the calculator to get the value of the I1 and the I2 easily. How will we do that? We will just use mode of this kind of calculator, the Casio calculator FX991ES Plus. This is what I'm using, but usually the Casio calculator has this feature. So what you do is you just press mode followed by the number 5, EQN, equation, and then you will see here number 1 with the X and Y variable and a constant here. So number 1, because we only have 2 variables, our variable will be I1 and I2. That's what we don't know. That will be equivalent to X and Y. And so I'll press number 1. Now here, we just need to write the number for our I1, which is 11.5. And then press the equal sign. After that, we have the second variable or second term, minus 6.8. So I'll press the negative, I'll press 6.8 and press equal sign, and press the 5, negative 5, minus 5, and then equal. So this 11.5 is representing I1, minus 6.8 is representing the I2, and we have the constant of minus 5. Then we continue with the next equation that we got over here. So how much did we get? We got the value of negative 6.8 I1. So negative 6.8 equals, and then 16.8 positive. So 16.8 positive equals, and then 15, 1.5 equals. And there you go, we got the minus 6.8, we have the 16.8 for the second term, and 15 for the constant. Now, all you have to do is to press equal sign, and the X will be representing the I1. And so, what we used was mode 5, okay, and number 1, right? Now, I know my I1. my I1 is equal to this value, we will just change it to a decimal number, which is 0.122482. 122482. So let's check it again. If it is correct, we have mode 5, 1, and after mode 5, 1, again, mode 5, 1, and then we write 11.5 equals, we write minus 6.8, so negative 6.8 equals, we write minus 5, okay, that's what we got. And we have another one, 6.8, so negative 6.8 plus 16.8, not plus, here equals first, and then plus 16.8, positive 16.8 equals, and 15 equals, and then press equal sign, and you got the answer of 0.1224823081 if you want to write all of the answers. And we will make it milliamperes because we are dealing with kilo ohms and we are also dealing with volts. Therefore, we can use milliamperes for our answer. Now the I2, on the other hand, we can press equal sign again, and you will get the answer here of 0.9424333.152 milliamperes. So, if we want to get the value of your I, let's say this is R1. Of course, the current that will go here is called IR1, right? So, IR1 is simply equal to I1 because IR1, and there's no other current there, is equal to I1. And our answer here will be 0.122, or let's just get 6 digits, 122482. Alright, well, let's get 122482 milliamperes. And then for IR2, the IR2 that we have, where's IR2 here, is the difference between I1 and I2. That's what we will get. And we got I1 is 0.122 and I2 is 0.942. So let's just assume that the difference of this would be the absolute value of 942 minus 122, or vice versa. So I'll just put here I2 minus I1, so I'll get 0.942433 milliamperes minus our I1, which is 0.122482 milliamperes, and I'll get the value of IR2 to be equal to, let's see, 0.942433, let's see, mode 1, and then let's copy this, 0.942433 minus 0.12248 equals 0.819, which equal to 0.819951, 0.819951. 951 milliamperes. Now, how about IR3? IR3, on the other hand, where's R3? Here, let's say this is R3 and this is R2, right? So IR2, the current here, IR3, this is IR3. And because there's no other current here on the right or up or down, we will say IR3 equals I2. So IR3 equals I2, which is 0.9424333 or 433 milliamperes. And there you go, we got our IR1, we got our IR2, we have IR3. So all of the currents now are known. So we can calculate for VR1, we can calculate for VR2, and we can calculate for VR3 by simply using Ohm's law, which is I multiplied with R, correct? And we can write here current of R1, resistance R1, current of R2, resistance R2, current of R3, resistance R3. And we will get the answer. So the IR1 is 0.122482 milliamperes, and the current IR2 is 0.819951 milliamperes also, and the current IR3 is 0.942433 milliamperes, and we will multiply them with the R1, which is 4.7 kilo ohms. We'll multiply it with R2, which is 6.8 kilo ohms, and we will multiply it with R3, which is 10 kilo ohms, and you will get the answer for the voltage. Now let's see what would be the answer here. Let's multiply 0.122482 multiply with 4.7, we will get 0.575665. So 576 volts. And then let's say 0.819951 multiply with 6.8, we will get 5.5756. So 5756 will be 6. And for this one, 0.942433 multiply with 10, we will get an answer of 9.424 volts. And there you go, we have our voltage on R1, voltage across R2, and the voltage across R3. We got our VR1, VR2, and VR3. Again, our I1 is not the current on R1, alright? This is the loop current that we use in mesh analysis, I1. And the current I2 is not the current on R2. It's only an assumed current I2 here, which goes with the loop that we wrote here. So we will say that the mesh analysis using loop currents can be used to calculate for the currents through R1, R2, and R3. And we can also use the mesh analysis to get the voltage. But we have to combine the mesh analysis technique that we did with the Ohm's law right here. We used here Ohm's law just to get the voltages. And what we used here in the IR2 is the analysis that I1 is equal to IR2 is the analysis that the current I1 and the current I2 have different direction. And since the I2 is bigger than I1, 0.9 bigger than 0.1, we assume that the I2 it will become I2 minus I1 because this is bigger. And so the direction of I2, we know also is going up. It's going up. This current will go up. Although there's a current going down, the current that will be here would be 0.8 milliamperes, which is going up. And the direction of the current on IR1 is to the right. The direction of the current of IR3 is going down. So this is going down and this is to the right. So as you can see, we can calculate for the values of the currents and we can identify what will be the direction of the currents. If we got here an answer of negative, let's say you did the IR2 equals I1 minus I2, you will still get the same number, 0.819951, but you will get a value of negative because you assume that the direction that will win between I1 and I2 would be the I1. You're thinking that I1 will be like the aggressive current, but it is not because I1 is only 0.1 and I2 is 0.8. Therefore, we used I2 minus I1. Now, if the I1 is bigger than the I2, I mean the value that we calculate here for I1 is 0.12 and the I2 is 0.9. Let's say this is bigger, then you can use this formula. Again, if you become wrong, you will see the answer will be negative. Then you know that the direction that you have chosen, which is going down, must become going up. Anyway, some questions for you in your examples may not be asking you to identify the direction, if it is going to the right or going to the left. I'm just telling you that you can identify the direction of the current. So I can tell that this is upward and I can tell that this is downward. So there you go. That's how to check how to calculate for the currents IR1, IR2, and IR3, VR1, VR2, and VR3 using the mesh analysis. And we use this mesh analysis if we have two sources here like this one. And that's it for today, and thank you so much for listening. We hope that you will support our channel ERC Tipsnology by subscribing, by sharing these videos, and you may also put some comments if you want. Thank you so much and have a nice day.